Just write this one. Physical interpretation of curl. Consider the motion of a rigid body rotating about a fixed axis through if omega bar is the angular velocity, then the linear velocity v bar of any particle of the body is given by v bar is equal to omega bar cross r bar, where r bar is equal to xi bar, yj bar, zk bar. Here r bar I have given general notation in the last class, xi bar, yj bar plus zk bar. From this, curl v bar is equal to 2 times omega bar. So therefore omega bar is equal to angular velocity is calculated by half times curl v bar. This justifies the name rotation used for curl. That is, curl of a linear velocity is equal to the angular velocity of the motion of any particle in the body, of the body. Curl of a linear velocity of the body is equal to twice the angular velocity of the rotation at any point. Curl of a linear velocity tells that twice the angular velocity of the rotation at any point of the body. Next. Physical interpretation of divergence. It gives consider a region of space filled with a moving fluid. let V bar is equal to Vx I bar, Vy j bar, Vz k bar. That is Vx, Vy, Vz are the velocity components in the x-axis, y-axis direction, xyz direction. B be a vector function representing the velocity of the fluid, then divergence of V bar, that is di V bar, gives the rate at which the fluid is originating at a point per unit volume in unit time. That is, it is the rate of the amount of the loss of the fluid per unit volume. So the fluid can be any vector field. Example, electric flux, gravitational field. Hence, di V bar is the amount of flux diverges per unit volume So this is the physical interpretation divergence. It gives the rate at which the fluid is originating at a point per unit volume. That is, it gives the rate of the loss of the fluid in unit volume, per unit volume in unit time. It can be electric flux or gravitational field. So that is, gives the amount of the flux diverges per unit volume. Fluid may be any vector field. Example, first problem. (1998) given an irrotational vector field f bar is equal to k1 xy plus k2 z cube ax bar plus 3x square minus k3z ay bar plus 3xz square minus y az bar. Full stop. Find del dot f bar at 1 1 minus 2. So the given field, vector field f bar is irrotational. So when do we say that a vector field is irrotational? Curl is equal to 0 bar. First find curl and equate to 0 bar. You will be getting k1, k2, k3 values. After obtained that values, for that f bar you find divergence, that is del dot f bar. Solution. F bar is irrotational, implies curl f bar is equal to 0 bar. That means how to find curl? Instead of ijk, here the terms are magnetic field terms, that is ax bar, ay bar, az bar. Ax bar, ay bar, az bar. Instead of unit vectors I bar, j bar, k bar, now these are some representation. Okay, different representation. Del by del x, del by del y, del by del z. F1, F2, F3. K1 xy plus K2 z cube 3x square minus K3 z 3x z square minus y. So this is nothing but, according to our notation, this is F1 and this is nothing but F2 and this nothing but F3, equated to 0 bar. And you know how to expand a 3 by 3 determinant. So this simplifies to ax bar into, closing first column first row, dou by dou y, partial derivative with respect to y, this value minus 1 minus dou by dou z of this term, that means minus k3, partial derivatives, minus center term ay bar into, close the second column first row, dou by dou x of this term 3z square minus dou by dou z of this term, that is 3k2 z square plus k bar, that is az bar into, closing last column first row, dou by dou x of this term 6x minus dou by dou y of this term k1x is equal to, I can write 0 bar as 0 times ax bar plus 0 times ay bar plus 0 times az bar, where ax bar, ay bar, az bar are unit vectors along x axis, y axis, z axis. They are denoted by, instead of I bar, j bar, k bar, this notation. Because two vectors are equal means corresponding coefficients are equal, then only you will be getting k1, k2, k3. So this quantity simplifies to right side again 0 bar. I wrote like that. So therefore, what is the simplification of this one? K3 minus 1 is equal to 0, and this is 3z square K2 minus 1 is equal to 0, and the last one x into 6 minus K1 is equal to 0. So therefore K1 is equal to 6, K2 is equal to 1, K3 is equal to 1. So therefore del dot f bar, that is divergence f bar. What I gave the notation? Del f1 by del x plus del f2 by del y plus del f3 by del z is equal to. For these three quantities, sum of the partial derivatives after substituting k1, k2, k3. So first value with respect to x means k1y, that is 6y, plus with respect to y this quantity 0, plus this quantity with respect to z 6xz, and the point where it is given 1 1 minus 2. So substituting here 6 minus 12, answer minus 6. So two problems based on this individually, curl and divergence, it is asked in gate question. I will be giving you along with answer if possible. Second example. (1993). Given V bar is equal to x square y I bar plus xyz j bar minus yz square k bar. This is linear velocity, comma, the angular velocity omega bar at the point 1 1 minus 1 is. Answer, what is the procedure given? Omega bar is equal to half times curl V bar is equal to, that is the hint. I didn't have the answer, you just calculate. I shown you already in the previous problem curl. In the same way, your first row is I bar, j bar, k bar, second row dou by dou x, dou by dou y, dou by dou z, third row I bar, j bar, k bar coefficients in the given vector V bar. Three. Two 2007. Divergence of the vector field V bar of xyz is equal to minus x cos xy plus y I bar plus y cos xy j bar plus sin z square plus x square plus y square k bar. Just you need to find divergence only. This is f1, f2, f3, sum of the partial derivatives with respect to x, y, z respectively. Answer is 2z cos z square. That you check. Fourth one. Find the value of a comma if the vector ax square y plus yz I bar plus xy square minus xz square j bar plus 2xyz minus 2x square y square k bar is solenoidal. Irrotational means curl is equal to 0 bar. Solenoidal means divergence equal to 0. In both cases, you denote I bar, j bar, k bar coefficients by f1, f2, f3. Answer A is equal to -2. Hint, div f bar is equal to 0. Hint, solenoidal means. This is I bar term coefficient f1, j bar coefficient taken to be f2, k bar coefficient taken to be f3. I have given in the definitions. So I am giving some results using divergence, curl, gradient along with vector identities. Sometimes useful, and based on these note points or results or formulas, whatever you consider, 2 times direct state that these results given. Okay. Div r bar is equal to 3. Curl r bar is equal to 3. 0 bar. Div r power n r bar is equal to n plus 3 r power n. Curl r power n r bar is equal to 0 bar. Del r power n, grad r power n r power n minus 2 r bar. The problems given with notation or words. Words means divergence, curl, gradient, like that. Okay. Del square r power n is equal to n into n plus 1. Better to by heart these things for saving time. All these things, results, number of steps, everything. Del square definition is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is dot product with itself only, del with del. This is summation dou square by dou x square is Laplacian operator in 3D. Next 3. If curl f bar is equal to 0 bar, then f bar can be expressed as gradient of scalar point function, where phi is called scalar potential function. Again, this is a physics application. In all these, here r bar is equal to xi bar plus yj bar plus zk bar. R is equal to root over x square plus y square plus z square. Just by heart these results using the given using the 4 differential operators: del square, gradient, divergence, curl, using the 4 operators. Next. Grad r bar dot a bar is equal to a bar, where a bar is constant vector. So while writing simultaneously, by heart these results. Vector identities. Grad phi psi. Phi psi is 2 scalar point functions. Phi into grad psi psi times grad phi, and write all these what I am giving the note points in word forms as well as notation forms, operator forms. Okay, so what is this operator? Del of phi psi, and this is phi into del psi, this is psi into del phi. That means results given like that, options. Next, div grad phi is equal to del square phi, and curl grad phi is equal to 0 bar. So this is curl means del cross, grad means operator form del, like that. Write in both notations. Write in both forms. One is notation form, other is with divergence, with curl, with gradient, like that. Div curl f bar is equal to 0, and curl, this is given 2008 or 2010, I don't remember exactly. Grad div f bar minus sigma dou square f bar by dou x square. What is the operator form? Similarly you write other results in the same formula. Divergence, one divergence is giving, one curl is giving. This is grad means del, div means del dot f bar. This is Laplacian operator del square f bar. Next, div f bar cross g bar is equal to g bar dot curl f bar minus f bar dot curl g bar. The last identity, div phi f bar is equal to phi times div f bar plus grad phi dot f bar. So this is phi into operator form del dot f bar, grad phi operator form del phi, and this is the question LHS asked in find del dot phi f bar, like that. And using curl phi f bar is equal to 5 into, just divergence is replaced by curl and dot is replaced by cross, plus grad phi cross f bar. So this is operator form del phi, and this is curl f bar means del cross f bar, and this is curl phi f bar in operator form del cross phi f bar. So this is one, this is second, this is third, this is fourth, and this is fifth. Fifth result. By heart these results. So this result curl f bar, it is in the problem 2 marks 2006 in one branch, which is given in the form of del cross p. That is, sometimes vectors are denoted by like this, or bold face notation, bold faces, that is thick letter. Example which is given, one example 2013, other example I already told you, using curl f bar, that is given 2006, 2 marks. 2013 for scalar fields phi and psi, comma, the value of del dot del phi cross del psi is del dot del phi cross del psi. Solution: del dot del phi cross del psi. Gradient is always a vector quantity. Let us denote this del phi by a vector f bar and del psi a vector denoted by a vector g bar, because gradient is a vector. Del phi is a vector, del psi is a vector. It looks like in the form of del dot f bar cross g bar, that is div f bar cross g bar. That is fourth identity what I gave. Okay. So this is equal to, what is this? Since divergence of f bar cross g bar is equal to what I gave, g bar dot curl f bar minus f bar dot curl g bar. Just use this identity and substitute there. That means g bar means del psi dot curl f bar means del phi minus f bar, that is del phi dot curl g bar, that is del psi. Now both curl of gradient quantity looks like in the form of one more identity what I gave in the note point. So this is curl grad phi 0 bar. So this is 0 bar, this is 0 bar. Dot product between two vectors where one vector 0 bar means the final value simplifies to 0, and which identity I have used, curl grad phi is equal to 0 bar. This is second identity. Third identity div curl f bar, fourth identity div f bar cross g bar, fifth identity. Okay, just remember that pattern. Next, complex vector integration. First one is line integral. Any integral which is to be evaluated along a curve or path, comma, is called a line integral. Is called a line integral. Okay. Now I am giving the notation for line integral. The line integral of a vector function f bar along a curve or path C is given by integral C f bar dot d bar is equal to integral C f1 dx plus f2 dy plus f3 dz. Since r bar is equal to position vector of any point with respect to the origin in space, xi bar, yj bar, zk bar, therefore dr bar is equal to dxi bar, dyj bar plus dzk bar. F bar is equal to, let f1 I bar, f2 j bar, f3 k bar. implies f bar dot dr bar f1 dx f2 dy plus f3 dz. So you know r bar, differentiate on both sides dr bar, take f bar a vector like this, then dot product gives scalar. This is scalar form of line integral, this is vector form of line integral, vector representation. So anyhow dot product is a scalar, so line integral this value is a scalar. So line integral of a vector function or any field f bar along a curve C is denoted by this one and is evaluated like this, okay, converted into scalar form. If f bar is the force acting on a particle moving along C, comma, this line integral represents the work done by the force F bar. So work done by the force is nothing but line integral F bar dot dr bar over the curve C. The next point is if f bar is equal to del phi, that is curl f bar is equal to 0 bar. F bar is conservative force field or irrotational. Then 1 integral P1 to P2 f bar dot dr bar is independent of the path joining P1 and P2 in R. Or you can write here, in a region capital R of space. Then first result, second result, integral over C f bar dot dr bar 0 around any closed curve C in R. So whenever f bar is irrotational, that is curl f bar 0 in a region R of space, then this line integral is independent of the curve or path joining any 2 points P1, P2 in R. So this is a rectangular region. Suppose curl f bar is equal to 0 bar. Okay. Then take any curve, take any 2 points. Between these 2 points there are so many curves joined or path joined. Take any path. So this line integral value independent of the path joining. That means no change in the answer. And if we take any closed curve in the field f bar where curl f bar is equal to 0 in the region R, then line integral value 0. These 2 points. Please by heart these 2 points.